All right, so here's the speed of light equation. We have the speed of light, which is c, equals lambda nu. All right, so lambda and then nu. Lambda is our wavelength. Oh, it says right here. Lambda is our wavelength. So it's either going to be in nanometers or meters. Frequency is going to be in hertz or per second or seconds to the negative first power, which looks weird, but remember, frequency is how many times does it happen per second, all right? So how many waves do you have per second, all right? And that's what this stands for. So it's the first time where we just kind of have a unit on the bottom, all right? Okay, let's go through a problem and see what we have. First, it says calculate the wavelength of yellow light if the frequency is 5.1 times 10 to the 14th hertz, all right? What do we know? We know the frequency because they just gave it to us. Now, instead of writing it in hertz, why would I write it in one of the other forms instead of Hz? What do you think? Exactly, yeah, so it'll cancel out later on. It'll make it much easier for us to remember what the units are supposed to be for our answer if we write it out like this. Or if you're really good at algebra, you want to just do the s to the negative first. That's fine too. I like to just keep it simple so that we can easily see what cancels out, okay? All right, so we know the frequency, we know the equation, we know what C equals also. 3.0 times 10 to the 8th meters per second, all right? So now we can start plugging everything in. So C equals lambda nu, all right? And for the work for this, you write down the equation, you substitute, you show your answer, all right? So C is 3.0 times 10 to the 8th meters per second equals, we don't know the wavelength, we're looking for that, and then times 5.10 times 10 to the 14th. Right there. Okay, how do we solve this problem? Yeah, Scott. Yeah, good. We divide to get this onto the other side so that we get wavelength by itself, all right? So we'll divide it by 5.10 times 10 to the 14th. 5.10 times 10 15th. All right, 1 over second. So on this side, this cancels out, leaving us just with wavelength. What happens with the units on the left side? Yeah, Scotty?
The seconds will cancel out.
Yeah, the seconds will cancel out. Does anybody know what actually happens to this for it to cancel out? Yeah, Scotty?
When you divide the fraction flips.
Yeah, when you divide, the fraction flips, exactly. So when we divide here with this 1 over s, what will actually happen is, as you said, it pops up over here as s over 1, okay? So if that gets rid of this on the bottom, and now you'll see the s's cancel out here. So we'll just cancel those out, leaving us just with meters, all right? So now you just take the numbers and you divide them. Make sure we can put them in our calculator correctly, right? Because it's scientific notation. So depending on your calculator, it might look like 3.0, that E button, and then the exponent, which is 8, divided by 5.10, that E button, and then 14. And then when you hit enter there, it should give you, now it's a small number, so I would say put it in scientific notation, okay? 5.88 times 10 to the what? -7. What are the units? Meters. All right, cool. Sig figs? Are we okay? Why are we good? because this is a constant, right? So we're not assuming this has 2 sig figs, we're just assuming it has unlimited, all right? So then you go with what's given in the problem. How many sig figs does this have? Yep, 3, right? Non-zero, non-zero, 0, but you have a decimal and a non-zero, so that makes that significant as well. So that would give us 3 sig figs for this. Okay, everybody cool with that? How do you check your answer? What would you do to check it? Yeah, Scotty?
You can take your answer and multiply by the equals to.
Yeah, if you multiply this by the given, what should you get? Speed of light, right? The constant. Yeah, you should. How else can you check? Non-mathematically. How could you check that you're right, not using math? How could you use this to check that you're right? What color did it say it was? It said yellow. So we look on here for yellow. Yellow is somewhere between here and here, right? So what's between here and here? Something like 5 times 10 to the negative 7th, right? And the answer we got was 5.88 times 10 to the negative 7th. Yeah, that's cool. Out of this whole spectrum, that's pretty close. I would say that we did it right. Good? All right, awesome.